Welcome to this explainer. Today we are pulling off the ultimate academic heist. Think of your upcoming Cambridge physics exam like a high-stakes, heavily guarded vault. You wouldn't just walk up to a massive steel door without a blueprint, a strategy, and a crew of specialists, right? Yet every single year, thousands of students walk into their exam halls armed with nothing but raw, memorized facts, just crossing their fingers and hoping it's enough to crack the code. Well, we are going to assemble your perfect cognitive toolkit to pull off the flawless answer heist, specifically targeting the cosmic microwave background radiation topic. Whether you are battling through Cambridge syllabus codes 0625, 0651, 0652, 5054, or even if you are taking those first advanced steps into 9702, the strategy we are going to unpack today is absolutely universal. We are going to decode the secrets to securing top marks straight out of the examiner's playbook. We'll uncover exactly what the people grading your papers are actively searching for, how top-tier candidates structure their answers, and how to entirely bypass the hidden tripwires that cost average candidates entire grade boundaries. It's time to transform your entire approach to physics exams.
Okay, let's dive right into the challenge by asking a massive, mind-bending question. How do we actually see the birth of the universe? This is exactly the kind of abstract, high-level concept examiners use to separate the top scholars from the rest of the pack. To really understand the challenge in front of us, let's look at a real, classic Cambridge 0625 past paper scenario, and let's examine two typical candidates. We'll call them Alex and Sam. Now they are faced with a standard, heavy-hitting question asking them to explain how cosmic microwave background radiation provides evidence for the universe's origins. Let's see what happens. First up is Alex. Now, Alex has studied hard, but when faced with the question, Alex totally panics. Alex just starts overloading the page with every single raw physics fact they can possibly remember. We're talking a massive data dump, writing furiously about microwaves, how microwave ovens cook food, optical telescopes, the speed of light, just an absolute wall of text with absolutely zero structural analysis. It is a chaotic, unfocused mess. On the other side of the exam hall, we have Sam. Now, Sam reads the prompt and thinks, "Oh, I know this instantly." Sam totally rushes the process, scribbles down one brief sentence saying, "CMBR proves the Big Bang happened," and slams the pen down. Sam completely misses the complex command word requirements hidden within the question. When the examiner gets these papers, what happens? If we put their answers side by side, it is just a tragic sea of red pen marks. Marks deducted everywhere. Why? Because neither Alex nor Sam decoded the command words, and neither of them structured their cognitive approach. They didn't have a system.
To fix this, we're breaking this explainer down into 4 strategic sections. Section 1, Origins of the Universe. Section 2, the expanding CNBR timeline. Section 3, the method mark strategy. And Section 4, top examiner traps.
Let's move right into Section 1, Origins of the Universe.
Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at the foundational knowledge. The crucial baseline fact you absolutely must know is that CMBR is observed everywhere, at all points in space, and was produced immediately after the formation of the universe itself. But knowing the definition isn't enough to pull off our heist. You need a system to deliver it. This is where we introduce the ultimate weapon used by top-tier students, the PEEL framework. That stands for point, evidence, explanation, and link. Let's break down how to apply this to our physics command words. The command words like describe, explain, or evaluate dictate exactly what you need to do. If the question says explain, use PEEL. Your point is your opening statement. The universe had a definitive beginning from a hot, dense state. Your evidence is the specific observation. We detect cosmic microwave background radiation. Your explanation is the heavy lifting. You explain that this radiation is observed at all points in space, in every single direction, with incredible uniformity, which proves it was produced shortly after the universe formed. And finally, the link. You connect this uniform radiation back to the core concept of an initial rapid expansion. I want you to imagine taking Alex's chaotic paragraph and running it through this PEEL filter. By forcing your answer into this exact framework, you instantly demonstrate analytical depth rather than superficial breadth. You are taking the examiner exactly where they want to go, step by step.
Moving to Section 2, the expanding CMBR timeline. Let's look at how energy transforms over cosmic history. Let's initiate a live rewrite for our student Alex right now. Watch this transformation. We're going to turn those red pen marks into beautiful, solid green check marks. To do this, we need to utilize the physics success blueprint, which demands perfect chronological flow. Instead of a frantic fact dump, Alex takes a breath, applies the blueprint, and writes out the sequence step by step. Step 1. The universe forms.
Step 2. A massive amount of initial, high-energy, exceptionally short wavelength radiation is produced in that ultra-dense environment. Step 3. And pay close attention, because this is the critical analytical leap that earns the top marks. As the universe expands, space itself stretches. It's not just things moving apart, the actual fabric of space is stretching. Step 4. Therefore, the wavelength of that initial high-energy radiation is stretched along with the fabric of space over billions of years, elongating it and pushing it all the way down into the microwave region of the electromagnetic spectrum that we observe today. Do you see the incredible difference there? Alex isn't just throwing facts at a wall anymore. Alex is telling a precise, chronological scientific story. It is a flawless chain of cause and effect, beautifully laid out for the examiner to award maximum points. This is how you show absolute mastery of a physics concept. You don't just state the end result, you walk the examiner through the mechanical process of how we got there.
Not to particularly lock this timeline into your brain, I highly recommend creating your own mnemonic strategy. You need a cognitive memory hack using the first letters of these key terms to lock in the expansion sequence forever. Think of the critical path: forms, initial, expands, stretches. F-I-E-S. You could use something like frogs in every swamp, or maybe fast ignitions expand space. It literally does not matter how silly it is, whatever works for your unique brain is perfect. When you're sitting in that exam hall, the clock is ticking, the pressure is immensely high, and adrenaline is pumping. In those moments, you absolutely do not want to be desperately fishing around in your memory for complex physics concepts. You want to trigger your cognitive mnemonic instantly to recreate this exact sequence, securing those critical knowledge and understanding marks without breaking a sweat. It's all about building reliable systems for yourself.
All right, Section 3, the method mark strategy. This is where we secure your points systematically. Stop scrolling! Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into the interactive workshop phase. Systematic processing isn't just a suggestion, it is absolutely mandatory. The method mark strategy is your ultimate safety net during the exam heist. Think about it. Even if your hand slips and you press the wrong button on your calculator at the very last second, a perfectly laid out methodical process will save the vast majority of your marks. Let's do a quick challenge. Imagine a highly complex physics data table on your exam, showing redshift wavelength measurements from 5 different distant galaxies. I'm going to give you a hypothetical 60 seconds. Your first step, according to our standardized sequence, is data scan. You must identify the key elements. You don't panic, you look at the axes, you check the units, you look for the core trend in the data. You don't jump to conclusions. Step 2, you apply the specific physics principle, in this case, cosmological expansion stretching those wavelengths. Step 3, you execute your analysis by physically writing down the formula before you plug in a single number. This shows you're working clearly. Step 4, you pause and verify your results. You ask yourself logically, does a microwave wavelength actually make sense in this context? And finally, Step 5, you present your final answer in the appropriate format with the correct significant figures. By ruthlessly following those 5 steps every single time, you systematically strip the method marks from the examiner's grasp. You leave them no choice but to award you the points.
Let's move to our next interactive challenge, find the flaw. I want you to remember that academic benchmarks firmly prioritize analytical depth over superficial breadth. The assessment framework rigorously demands logical, structured reasoning, and it continuously evaluates your ability to identify limitations over simply memorizing facts. Listen to this deeply flawed sample paragraph from a mock exam. The CMBR is everywhere, and it shows the universe is big. The wavelength is microwave because it cooled down. This proves everything. Okay, pause. Take a moment. What exactly is losing marks here? The examiner commentary on an answer like this would be absolutely brutal. The central fatal flaw is a total lack of analytical depth. Saying it cooled down completely ignores the actual fundamental mechanism of space expanding and physically stretching the wavelength. It's a massive oversimplification. Furthermore, boldly claiming this proves everything is a massive red flag. It completely fails to identify specific scientific limitations or alternative interpretations. Academic benchmarks require absolute precision. You must deploy precise, professional terminology like cosmological redshift or the expansion of the fabric of space, completely avoiding those overly simplistic conversational summaries that cost students so dearly.
Finally, Section 4, Top Examiner Traps. We're opening the playbook to see exactly where students fail.
Let's expose the specific patterns of failure that cost candidates their grades every single year. Principal examiners continuously report these 3 major errors: mixing up the timeline of expansion, ignoring strict formatting conventions, and writing generic answers. Let's break these down to ensure you never make them. Mistake number 1, confusing cause and effect.
Under pressure, students often write that the cosmic microwave somehow caused the universe to expand, rather than the expansion of space causing the initial radiation to stretch into microwaves. It is a fatal flaw in logic that instantly caps your grade. Mistake number 2, format and presentation. This is heartbreaking. You do all the incredibly hard cognitive work, the complex math, but you forget the appropriate heading, you drop the standard SI units, or your annotation is just an illegible scribble on the side of the page. The examiner literally cannot award marks for brilliant physics that they cannot read or understand. And mistake number 3, which is frankly the absolute biggest trap of them all, providing generic answers. You memorize a perfect textbook paragraph the night before, and you just blindly copy-paste it onto the exam page, completely ignoring the unique, specific scenario that the question actually presented. Now, let's do a 30-second speed writing challenge in your head. If the question asks about a satellite detecting CMBR, you need a peel paragraph that mentions that satellite, not just a generic universe definition. You have to actively build a time management matrix in your mind, allocating specific minutes to read, decode, plan, write, and verify, so you never fall into these traps.
Let's really hammer this home by comparing a generic answer that lacks specific problem details against a high-mark, context-specific answer that links directly to the given scenario and makes crucial cross-topic connections. Imagine the exam question specifically asks about CMBR data being collected from a newly launched deep space satellite. A generic low-scoring answer just defines CMBR in a vacuum. It ignores the satellite entirely. A context-specific top-tier answer explains exactly how that satellite's specific onboard instruments measure those exact microwave frequencies, cross-referencing other Cambridge syllabus topics, like the electromagnetic spectrum, wave properties, and even satellite communication principles. You have to expertly weave the specific data from the prompt into your scientific explanation. This brings us to the complete physics answering system. There are 3 unbreakable rules that guarantee top marks. Rule 1, command word decoding. Never answer before you know what the verb demands. Rule 2, Peel framework application. Structure your logic flawlessly. And Rule 3, the time management matrix. Pace your heist so you get in, get the marks, and verify before time runs out.
This isn't just my opinion. This is a direct examiner alert straight from the Cambridge grading rooms. The report explicitly states the classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. This serves as your ultimate warning to integrate your physics knowledge with the exact problem in front of you. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. It is about building intense cognitive muscle memory, so that on exam day, you are executing the perfect structural response completely flawlessly without hesitation. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @theacetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. As we wrap up this explainer, I want to leave you with a crucial provocation. How will you adapt your newly built systematic process to absolutely conquer the next context-specific exam question you face? Are you going to be an Alex, desperately overwhelming the page with a chaotic dump of random facts? Are you going to be a Sam, recklessly rushing past the command words and leaving marks on the table? Or are you going to step up and be the strategist, calmly and ruthlessly executing the Peel framework, utilizing your time matrix, and systematically securing every single possible method mark? The entire blueprint is right in front of you now. You have the tools, you know the traps, and you have the strategy. The vault is waiting. How will you execute your perfect exam heist?